Representation of curves. There are mainly two mathematical methods for representation of curve. Non-parametric representation and parametric representation. Now what is the non-parametric representation? The curve represented as a relationship between the x, y and z coordinate. Like function of x, y, z equals to 0. The totally equation is based on the x, y and z relation or in the form of x, y and z coordinate. Like we take one example of circle. So the main non-parametric equation for the circle is ax square plus by square plus 2kxy plus 2gx plus 2hy plus c. Now we can easily see the totally equation is based on the x, y and z coordinate. So it can be easy to remember that the non-parametric representation have a relationship between the x, y and z coordinate, and the non-parametric representation is based on the coordinate system. Now we take example under the example of ellipse x square by a square plus y square by b square minus 1 equals to 0. So here also the x coordinate and y coordinate, all the full equation is based on the x and y coordinate, and the here z coordinate is 0. Now let's see what is the parametric representation. The curve is not represented as the relationship between the x, y and z coordinate. So here in the parametric equation there is no any individual, or we can say that equation is not based on the x, y and z coordinate, but as a function of independent parameters such as u and theta. Like the form of parametric equation is x equals to x of u. So the x is a function of u, the y equals to y of u, the function of u, and the z equals to z of u. So this is the main form of the parametric representation. Now we take an example of circle. So here the x equals to r cos theta and y equals to r sin theta. So here theta is the independent parameters. Like here for theta is an angle and r is a radius for circle. So here this is the form of the parametric representation for a circle. Now let's see some limitation of non-parametric equation or curve. It cannot be used for representing the closed curves like circles and multi-valued curve like ellipse, parabolas and hyperbolas, because it is very difficult to equate all the equation for the multi-valued curves like ellipse and parabolas. Like the second point, if the straight line is vertical, then the slope is infinity. Such values are difficult to handle in computation. So this is very difficult to handle or difficult to calculate the computation of vertical line. Now the equation requires solving simultaneously. So there are x, y, z coordinate in the non-parametric equation. So we need to required to solve every equation one by one. So it is very lengthy procedure also. Now the equation of curve depends upon the coordinate system like x, y, z. It is the basis of the non-parametric equation. Now what is the advantage of parametric curve? Not a non-parametric curve, it is the advantage of parametric curve. It is used for the closed and multi-valued curve. Closed as a circle, multi-valued curves like ellipse, parabolas and all. Now it can replace slope by a tangent vector. So it is easy to calculate the every equations. Now for conic and curves, the parametric equation uses the polynomial rather than the solving roots. So it is used the polynomial which can be easy to solve every equation rather than the solving roots. Now it is suitable for partial curves also. So these are the main parametric curves advantage.